Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 7 of a unit Laws of Motion. In today's class we are going to discuss about the friction. This is the introductory session of friction. Maybe it is possible that you have gone through this all concepts and these theories in your previous classes, but to understand the friction in a very good manner, this is required. So let's just begin. We are going to discuss all the theoretical aspects, all the macroscopic and microscopic level of the friction. So let's just begin and have a focus on this. First question, what is friction? When we say friction, it is the property which opposes the relative motion between the bodies in contact and acting tangentially to the surfaces in contact. First misconception is that friction opposes the motion. It is absolutely incorrect. When you say friction opposes the motion, you are 100% incorrect. This is not the case. Friction opposes the motion. No, this is not the case. Friction opposes the relative motion between the bodies in contact. How this two, friction opposes the motion and friction opposes the relative motion, how these two are different, we are going to discuss it in this session. But please do remember that friction does not oppose the motion. It opposes the relative motion between the bodies in contact. First thing, it opposes the relative motion. Second approach, for friction to be act, the two bodies should be in contact. So it is always the force when two bodies are in contact. If two bodies are not in contact, friction is not acting. Second and third, very important aspect, that it acts tangentially to the surfaces in contact. It always acts tangentially to the surfaces in contact. I hope these things are clear. Is it clear? It always acts tangentially to the surfaces in contact. Now, friction may be defined as the opposing force which comes into play tangentially between two surfaces in contact so as to destroy the relative motion. Even one more time, it is not destroying the motion, it is destroying the relative motion between them. I hope these things are clear. Is it clear? Is it clear? Great. Now let's have a look at this bicycle case. When you want to stop this bicycle, you press the brake and it slows down because of the friction between the brakes and the wheels. So look at this mechanism. Yes, wheels have been attaching here and it is somehow caliper, and this is the brake pads. You just apply this brake pads and there is force, there is a force of friction between the brakes and the wheels, and that's why it is going to be stopped, or its speed is going to be decreased. Yes, this is the one of the case where friction acts. Now one more thing, different solid objects experience different amounts of the friction. Why? We are going to have a look. Yes, let's look. An eraser on a glass top table will experience more friction than a coin, which will experience more friction than an ice cube on the same table. Yes, so different solid objects experience different amount of friction. So it depends on the pair of the mediums. It depends on the pair of the mediums on which it is going to be acted. Is it clear? Great. One more thing, please ask the question that why do you slip and fall when the floor has just been mopped? Why this happens? Or this is the situation in the rainy season especially. There are more chances that our vehicle probably two-wheeler or the four-wheelers, there are more chances to get it slipped in the monsoon season as compared to the summer or as compared to the winter. Why this happens? Because this liquid creates a thin layer between the floor and your shoes. When two-wheeler slips, it's that liquid that forms the thin layer between the road and your tire, and it reduces the friction a lot. So we observe many accidents during the monsoon because of less frictions between the road and the tires. So now I need to focus on one more thing, that due to friction, now as the friction reduces, you have been just slipped. So it is the friction due to which we can walk. Do you agree with this statement? It is the friction due to which we can walk. As here the friction reduces, there are chances to be getting slipped. Do you agree with this? If you agree with this, let me ask you the second question. So initially when you discuss that friction opposes the motion, when you have been asked what is friction, your first answer would be, sir, friction opposes the motion. How is it possible? Because we can walk due to friction only. If we can walk due to friction, how it opposes the motion? No, this is absolutely incorrect. That's why in first slide I have cancelled it, that friction opposes the motion. I hope these things are clear. Friction doesn't oppose the motion, it opposes the relative motion between two objects when they are in contact. Is it clear? Now is it clear? Great. Now let's look at the causes of friction. How friction arises, or why friction arises. You can see that the surface of any body appears as a combination of ups and downs on placing one body over another body, and few of the elevations on the first body set into few of the depressions on the second body. The situation will be something like this, that let's say suppose this is a table, and over this table one of the book has been kept. Now if you observe in the normal situation, this too looks a very smooth surfaces, but if you magnify it, if you magnify this situation, the table surface could be seen something like this, and the surface of the book could be seen something like this. So it is something like this. It is obviously, this is at microscopic level, yes, but it is there. So surface of these two bodies have certain ups and downs. We could say it as an elevation and depressions, and few of the elevations of the first body has been set into few of the depressions on the second body. So it can be observed as these two surfaces are having an interlock with each other, and due to this interlocking, motion of the one body over the other body is restricted. Yes, it is this interlocking which provides us a friction. It is due to this interlocking between two surfaces which will give us the friction. I hope these things are clear. Yes, so when the irregularities on the surfaces are completely removed, the molecules on either surface will come close, and the adhesive or cohesive forces between them opposes the relative motion, and hence the friction may increase. Now maybe the question is, sir, what is adhesive force? It is the force between different bodies. And what is cohesive force? It's a force between it's a force between similar bodies. That means, let's suppose take a case of water is acting a force on water. It is a cohesive force. But let's suppose water is acting certain kind of force on glass surface. This could be considered as an adhesive force. That's why, if you remember the Fevicol, have you remembered this Fevicol? Yes, Fevicol is considered as an adhesive. That's why it is an adhesive material. I hope this is clear. Is it clear? Yes, let's get back to this. So what we were discussing is that when the irregularities on the surfaces are completely removed, the molecules on the either surfaces will come close, and the adhesive or cohesive forces between them opposes the relative motion, and hence the friction may increase. Now, so if the surfaces are identical in nature and are very smooth, cohesive forces are increases, and that increases the friction. That means initially the situation was something like this that we have discussed. This was the first object and this was the second object. Now let's suppose by somehow we managed to get it something like this. So now if this two surface will come closer as before, and due to this certain kind of forces do acting, maybe cohesive, that means of same nature bodies, or maybe adhesive, and due to this friction can arise. So the work done in overcoming friction by the applied force may result in heat and cause a sort of thermal welding between the surfaces. Hence it is difficult to predict friction exactly. We don't know what amount of friction is acting between this two surface exactly, that what amount of friction is going to be acted. Yes, it depends essentially on the nature of the surface in contact and the normal pressure between the surfaces. So up till now we might have this two idea. Yes, we might be wrong, but up till now we have two ideas that friction may be depend on the nature of the surfaces in contact. It depends on the nature of the surfaces in contact, and it depends, thus friction depends on the normal pressure between the surfaces. So this is just the conclusion from all the observations, and we don't know anything else about this, but we might sure that that it depends on these two parameters. Let's have a look. Friction is generally, if the surfaces are smooth, yes, if the surfaces are smooth, friction is more. Yes, because it is having cohesive or adhesive forces, and if cohesive or adhesive forces are there, yes, it will going to very difficult for us to overcome this friction. Yes, next, frictional force between two surfaces is in contact. Frictional force between two surfaces in contact is due to adhesive or cohesive forces between the molecules. Yes, it is correct. Only cohesive force, no, this is not correct. Repulsive forces between the molecules, yes, even it could be there. So this should be the answer. Both B and C should be the answer. Yes, this is the answer because both options are correct. I hope this is clear. Is it clear? Is it? Now let's look at the advantages of friction. What are the advantages of friction? Yes, friction is very much necessary to produce a controlled motion. Controlled motion. Every time we were looking for the controlled motion, we just not wish it is a motion. We always look, or we always go for the controlled motion. Motion of your vehicle. should be a controlled motion. Yes, that's why brakes are there. That's why brakes are there, to have a controlled motion. The surfaces in contact will sleep on each other without opposition in the absence of friction. Yes, suppose this is the first surface and let's suppose this is the second surface. If between this there is no friction, if between this there is no friction, then it is the situation that this surface may glide over it, or this surface just slide over it, and you don't have any control over this. Yes, this could be the situation if no friction is there. So it is the friction, which will not allowing these two surfaces to glide over and just wash it out. I hope these things are clear. Yes, yes. Friction between the floor and the foot enable us to walk safely. Yes, this is the much needed. Yes, friction allows us to walk. If no friction, no motion is possible. Yes, nails and screws can be driven into the walls due to friction. If no friction, even this cannot be done. Yes, invention of fire was a result of friction between two stones. Yes, we have heard this, that those people used to rub two stones with each other, and due to the stones certain sparks have been developed, and that sparks they were using as a source of an energy. Yes, moving wheels can be stopped due to friction. Look at this man is trying to do it. Yes, but don't wait it until it gets burnt. Yes, just go through the next video. Yes, okay, let's have a look. Yes, friction is greater on rubber surfaces, and so that the grooves in the rubber tire are made to reduce the smoothness of the tire and increase the friction, which helps avoiding skidding of the vehicles. Yes, we want that friction should be there. If no friction is there, our vehicles can get skied away easily, very easily. So you might understand that as soon as the tire gets older, that means when your vehicle has been overridden, and let's say suppose if it's a car, your tire has been used for approximately 40-50,000 or more than this, 40-50,000 kilometers. These grooves have been wiped out, and when this grooves has been wiped out, it is advisable to change the tire, because now friction would be less. So it is possible that when you ride your car and a sudden brake would be applied, or let's say it is a season of monsoon and rain has been there, and you apply a brake, then there is a chances to getting skid. Yes, so in this situation we want that friction should be there. This is the advantage of friction. Yes, because friction is there to help us control the motion. Yes, one more situation. Our planet, the earth, which whirls into outer space, if friction was present in outer space. So in outer space, friction is absent due to this planets continue whirling in their space. So if friction was there, in the outer space as well, our planet has been moved away from the system. Yes, and it is constantly moving around the sun, because there is no friction in the outside the planet. Yes, so this all are the advantages of friction. Yes, now let's look at the disadvantages of friction. Let's have a look. All the disadvantage. Yes, so first, wear and tear between the machinery parts increases and reduces their life due to friction, as two wheels, when they are in contact, they are going to have a friction between them, and when they are having a friction between them, they will produce a wear and tear. and due to this wear and tear, between the machinery parts, their life is decrease. Yes. Next, some energy gets converted into heat, and this heat is total waste due to the friction. A large amount of power loss in machines and engines, and hence brings down their efficiency. As there is a loss of energy, there is a loss of power, so its efficiency will be reduced due to friction. Now let's just look at the methods to reduce the friction, because the situation is, do you want friction? The answer is yes, we want the friction. Then the second question is it okay if due to friction your efficiency is reduced? We say no, it is absolutely not okay. So what could be done? We understood certain trade-off. While I say trade-off, we means we want a friction, but we want a lesser amount of friction. So what we can do, we can use certain methods which can reduce the friction. So friction would be always there, but but the amount of friction can be reduced. How? Look at this, using lubricants. Yes, you might have heard the certain mechanics that service our vehicles, that engine oil is over, I need to replace it, I need to put an engine oil over it. So while I put engine oil, or while I put any lubricants, that will reduce the friction between the surfaces in contact. And how it is reducing the friction? It will form a thin layer of oil or a fluid is used. Yes, in general the lubricants such as compressed air or organic oils are used. Yes, so this is one of the method by which we can reduce the friction. Second approach is polishing. By polishing the surfaces, irregularities on the surfaces can be removed, so friction decreases. If you remember, in the beginning we were discussing this kind of depressions and impressions. So if I polish the surface, it would be possible for me to generate this kind of surface approximately. So when I am able to produce this kind of surfaces, this irregularities has been gone, and when this irregularities has been gone, the friction decreases, and this is due to increase in the adhesive or the cohesive forces. Yes, but the problem is, friction increases when bodies are heavily polished. When bodies are heavily polished, friction increases. So this is due to increase in adhesive or cohesive forces. So you need to always consider a moderate level of polishing, because if you polish it above certain level, if you polish your surfaces above certain level, it will not decrease the friction, but it will increase the friction. Yes, if you remember the carom board, yes, if you sprinkle a certain kind of talcum powder kind of thing, yes, talcum powder kind of thing has been sprinkled on the carom board so that striker as well as coins can move on the carom board very smoothly. But if you put on a higher amount of talcum powder, then it will increase the friction, not it will decrease the friction. Yes, so even while you polish the surface, you must understand that beyond certain level it is going to increase, the friction, and it is not going to decrease the friction. I hope this is clear. Next, using ball bearings. Yes, this is one of the best possible approach to reduce the friction. The free wheels of vehicles are provided with the ball bearings to reduce friction, as they convert sliding friction into rolling friction. Yes, so when I use to have a ball bearings, yes, it is going to slide one surface over the second surface. Look at this, not complete two surfaces are in contact, only this part is in contact. If you look at any of the sections, only this much amount is in contact, so only this much amount is having a capability to produce a friction. Yes, so this will this will surely reduce the friction for us, and this is the best possible approach to reduce the friction. Next, by streamlining. Yes, automobiles and aeroplanes have the spatial design. They are the streamlined to reduce the friction due to air. That's why their shape is something like this. Yes, this is the streamline. Yes, when they are in motion, friction is reduced due to air. Yes, that's why it is the perfect shape. Yes, it's a streamlining of shape. Yes, great. So let's have some questions. Blank are the methods of reducing friction. Using lubricants, yes. Using polishing the surface, yes. Using ball bearings, yes. So this would be the answer, all of the above. Is it clear? Great. Next, which of the following is wrong? Using ball bearings, sliding friction changes to rolling friction. No, this is correct. Lubricants decreases friction since intermolecular forces are weak in liquids. Yes, this is correct. Over polishing increases friction since moleculars come closer. This is correct. So which one is wrong? None of this is wrong. Yes, are you clear with this? Are you clear with this? Any doubts in this, or any doubts up till now? Is there anything? Are you sure? Okay, great. Let's discuss types of friction. Types of friction. Basically, there are three types of friction. We can consider them. They are the static friction, sliding friction, and the rolling friction. We are going to observe this one by one very carefully. Yes, even this is very important aspect according to the theories, as well as to understand the concepts, how friction arises, why friction arises. So let's begin with the static friction. What static friction is? When we say that frictional force acts between two bodies which are in contact but are not sliding with respect to each other, the friction in such case is called static friction. If you want to have one more clarity, if you want to have more clarity, go with it one more time. When it says that frictional forces act between two bodies which are in contact but are not sliding with respect to each other, the friction in such case is called a static friction. It is something like that suppose a person is trying to push a heavy almirah on the floor. He has to push it strongly to overcome the static friction between almirah and the floor. It is something like this. Let's suppose this is the object and he is trying to pull it, or let's suppose he is applying a force from this direction. He is trying to make it move, but he is not able to move. In this situation, the friction between these two, that is the friction between the surface and this friction between this box, or you can say friction between the almirah, is very much higher, so that it is just not slipping over it, or it is just not sliding over it. Then we can say that the friction between this object and this floor is the static friction. I hope the things are clear. Let's say, suppose it is the situation exactly. Yes, it is the resistive force that acts when there is no relative motion between the surfaces of the bodies in contact under the action of external force. So if no external force is there, please understand this statements very carefully. If no external force is acting, it means no frictional force can arise. Yes, at this point of time, just remember this statement, and on later on sections we are going to discuss this in a very detailed way, so that if no external force is acting between the bodies, that means no friction is there. But here you are trying to push this almirah. So if I make a FBD of this almirah, yes, this is the force that you apply, and this is the static friction that do exist between this almirah and the surface. Let's say suppose if your applied force is less than static friction, that means this is not going to move. Yes, we can even say that the static friction is self-adjusting force, and it is represented as Fs. S would be used as a subscript, and that stands for the static. I hope these things are clear. Is it? What self-adjusting means, we are going to discuss about it very soon. But is it clear up till now? Yes. Take one more case. Let's say that this block B is there, which has been kept on the surface, and this surface is not smooth. That means it is having a friction. Consider a block B which is placed on a horizontal table, which is connected to a small pan by means of a string with the help of a frictionless. This pulley is frictionless as shown in the figure. Now, what was the situation? Initially, when there was no weight in the pan, the block B does not slide because the frictional force between the block and the table is balanced by the applied force. Initially, block was not moving. Why? Because there would be no weight in this pan, and it is applied by certain force here. Yes, that could be due to the weight of the pen, and it has been having the frictional force in this direction. If these two are equal, this block B is not going to move anywhere. Yes. Now the situation is that we are going to put up certain weight in the pen, and let's say the body may still be static. That means let's take an example that let's suppose the total pen weight of the pen is, let's understood, it's a 10 Newton, and in this situation the block doesn't move. That means I must understood, or I must assume that my friction is 10 Newton. Why? Because it can balance the block B, and as it can balance the block B, that means it is not moving anywhere. Why not moving? Because it can balance the weight of the pen. Now let's suppose I have added up some certain weights in this path. So it's a pen plus mass. Yes, that is, let's say 20 Newton. But even if now it is a 20 Newton, let's say this B is not going to move. So I must understand that no, my friction was not 20, it should be a 20 Newton. I'm going to add some few blocks more. It's a, let's say 30 Newton. Even though my block B is not moving, then I must consider that my friction should be a 30 Newton. If I have put up certain more forces, certain more blocks, it's a 40 Newton, then I must consider that my friction should be a 40 Newton. Now look at this. Initially what I considered that my friction was 10 Newton. Then I have considered my friction would be a 20 Newton. Then I have considered my friction is 30 Newton. Then I have considered the friction is 40 Newton. This is what self-adjusting in nature is all about. That's why in the previous slide it was mentioned that static friction. Look at this. It is self-adjusting force. It is self-adjusting in nature. That it is going to adjust it according to the external force is being applied. Yes, it will be definitely having a certain maximum value up to which it can adjust itself, but this is the self-adjusting in nature. I hope these things are clear. Is it? Great. So the body does not move because the resultant force on the body is 0, that we have discussed, and the frictional force is equal in magnitude and opposite in direction to the applied force B, and it tangential between the two surfaces. Even this is very important. Friction always acts tangentially. Yes, Friction always acts tangentially between the two surfaces that are in contact. Is it clear? Great. Now, the maximum value of static friction, beyond which it cannot increase itself, is called as the limiting friction. It is the maximum value of static friction that we call as an Fs max, and this Fs max would be equals to Fl. It's a limiting friction. And the coefficient of static friction is usually less than 1. Yes, what is it? We are going to discuss very soon. It's a mu s would be less than or equals to 1, and static friction is equivalent magnitude of applied force, but it opposes the applied force. That means it is going to be applied in the opposite direction. Again, it is going to be applied. I am talking about the frictional force. That frictional force is going to be applied in the opposite direction than the direction of the applied force. Here I am not making anything that friction is opposing the motion. No, it is not opposing the motion. It is just opposing. It is just opposing the relative motion between two surfaces, and it is not opposing the motion. Please make this very clear. There is a huge difference between opposing the motion and opposing the relative motion. Yes, great. Let's look at certain MCQs. The maximum value of static friction, yes, that is the limiting friction. It's a maximum value of static friction that we call as a limiting friction. Next, the coefficient of static friction is, it is usually, not a usually, it is always less than 1. Yes, coefficient of static friction is always less than 1. Yes. Now let's move to the dynamic friction or kinetic friction. Most of the authors call them as a kinetic friction. Yes, even NCERT has mentioned over it as a kinetic friction, but there are few authors which mention it as a dynamic friction. So if you read any of the reference book and they have mentioned the dynamic friction, it is same as the kinetic friction. Now let's take back the same example that we have used for the block B, that at a particular value of the weight, if you remember the previous story, that initially there were no weights put up in the pen and block was at rest. Then we have started putting up the weights in this pen and still block was not moving. So we called it as friction is self-adjusting itself. Now if this story is moving on a forward side, that means we are going to add weights in this pen at a particular value of the weight in pen. The applied force overcomes the limiting frictional force and the body is set into the motion. At this condition, the body encounters another friction. That is what we call as a kinetic or dynamic friction. It is the situation or it is the instant at which body just starts sliding over the surface, over this table. At that time, whatever the friction is acting on the surface, that we call as kinetic or dynamic friction. Yes, the resistance encountered by a sliding body on a surface is known as a kinetic friction or dynamic friction. Even we sometimes used as a sliding friction. Is it clear? Is it great? Now dynamic friction is also called as the kinetic friction. Yes, that you know. Now let's understand in more detailed way difference between static and kinematic friction. Let's have a look. Yes, this is very important graph. Yes, even concept wise as well as exam point of view, this is very important. Yes, what we have done is we have plot a graph on taking applied force on x-axis. This is the applied force, and frictional force frictional force on the y-axis. While to plot this, you can consider a block on the surface of another body which is under the static friction. So initially what was the situation? The situation was that something like this. Let's suppose this is the block and you are going to pull it so that it should start moving, but initially it is not moving. That means you understood that my effort, my external force is same as the frictional force. So what you are supposed to do is you are going to increase the external force. This is the sign for the increasing. But initially, as soon as I increase the F external, my friction also increases, and this will move on. Yes, the friction also move on. Suppose, let's say, suppose this is the situation that even this is increasing. This can be seen from this section. I hope these things are clear. Yes, that I am increasing the applied force, and as soon as I am increasing the applied force, my static friction, look at this, my static friction starts increasing. It is increasing. Yes. Now at a certain stage of life, a situation arises where it starts moving. So this, if I increase the F external beyond certain point, the F static has been vanished and F kinetic has started. So this is the limiting friction. This is the maximum value of static friction. So from now onwards it is moving like this. You can observe this very carefully, that this kinetic friction is less than limiting friction. Yes. Why this happens? This is all the theoretical aspects. You can go through with this. For your reference purpose, because you need to write it down certain things technically in your question papers. Yes, so this is, I have written all this thing that we have discussed. So this is the kinetic friction when the block is about to slide down, and this kinetic friction is slightly less than the static friction that we have already discussed. Now let's differentiate static friction and kinetic friction. We can say it is equal to the applied force and magnitude. Kinetic friction, it is equal to the applied force in magnitude only when it is sliding with constant velocity. Yes, when a block or an object is moving with constant velocity, we can say the value of kinetic friction is equal to the force applied, or I can say it's an external force applied. Next, it is opposite to the applied force in direction. It is always opposite to the direction of velocity of sliding. Yes, so let's have a look at this. A kinetic friction is always opposite to the direction of velocity of sliding. It is opposite to the applied force in direction. It is equal to the applied force in magnitude. What is it? We can say it is always opposite. It is always opposite to the direction of velocity of sliding while we are talking about the kinetic friction. I hope this is clear. Is it clear? Is it? Great. Next, sliding friction is always less than sliding friction. That means we are talking about the kinetic friction. This kinetic friction is always less than the static friction. Please do remember this, that kinetic friction is always less than the static friction. I hope this is clear. Is it clear? Any doubts on this? No? Great. Now let's start the rolling friction. It's a last friction. Yes, we have started with the static friction, then dynamic or kinematics friction, and then it's a rolling friction. Now what is rolling friction? We can say it's a force of friction comes into play when a body rolls over the surface of another body. Yes, now you understand by practicality in life as well that it is always easier to roll than slide a body over another body. Yes, it is always easier to roll, and that's why we have kept most of the objects on a rolling roads, on a rolling wheels. Yes, even all these objects are having the rolling friction only. Yes, so this is direction of motion, and you can see this is the force of friction. Yes, you can understood that the force of friction is opposite. The force of friction is opposite to the direction of motion, and we can say the force of friction between the rolling body and the surface is called, whatever the force that is being acted over here, it is the rolling friction. I hope this is clear. Is it clear? Let's have a look. This are the examples of the rolling friction. You can see it here, that from here it's a rolling friction that do exist. At here, at this wheels rolling friction is working over here. Yes, even you can see if ball bearing kinds of things are there, so even they are going to roll it, and when they are going to roll over one another surface, then they are having one kind of friction, and that friction we call it as a rolling friction. Is it clear? Is it? Great. So when a spherical body rolls on the horizontal surface, then the speed of the body goes on decreasing and finally it stops. The opposing force acting between the surface of the spherical body and the horizontal surface is named as the rolling friction. This is rolling friction. This, let's suppose this spheres have been kept on the ground, and I'm going to apply a pushing force over here. It's an F external. So if this is going to slide over the spheres, this is going to slide over the friction. So this is the direction of motion and this is the direction of friction. It is always in the opposite direction. Yes. So because friction is going to oppose the relative motion between the sphere and between this block. Yes, that's why if you push it and leave it alone, if you push it and leave it alone, that means this is going to stop after traveling a certain distance. Yes, because this is the friction which is opposing the relative motion. I hope these things are clear. Is it clear? Is it? Great. So let's understood this. The necessary condition to roll the center of mass of a roller at constant speed on a rough surface, at a constant speed on a rough surface, is that there should be a component of the applied force parallel to the surface. So if I want that my block should be always moving, I need to apply a constant amount of force if friction is there. If no friction is there, we do not require any force. Yes, so this force component is numerically equal to the rolling friction, and this rolling friction is slightly less than the kinetic friction, and which is less than the static friction. So this would be the situation: static friction having the maximum value, kinetic friction having lesser value as compared to the static friction, and the rolling friction even it would be the lesser than the kinetic friction. I hope this is clear. Is it? Let's have certain MCQs. The order of friction is always as, yes, static friction maximum, then it would be the kinetic friction, and then at least it would be the rolling friction. It is, that's why it is easier to roll the objects as compared to slide the objects. Yes, that's why it is easier to roll the objects as compared to the slide the objects. Okay, rolling friction equals to static friction? No. Greater than the static friction? No. It is less than static friction. Yes. So third would be the answer. Yes. Great. rollers are there which is used to reduce the friction. Is it clear? Is it? Yes. So let's wind it up this session over here. Yes, this was the session where pure theoretical section was there. Yes, because the concepts or the detailed concepts of friction is very required, because these are the concepts which through which we are going to build our sessions of friction for class 11 as well as class 12th. Yes, so this theoretical session was required. Yes, I hope you enjoy this. Yes, after a very long time that there was one of the session where only theories were discussed. Yes, I hope you might find interesting in it. So let's just end it. But before I end it, please, I request you guys to revise this before you tune to the next session. Even it would be the part 2 of the friction. Yes, so before going to start that video, please revise it. Thank you. Have a good day. Take care. Bye bye.